Okay, let's start. I think it is time to start. Okay, so this is week 5, and I'm Jyoti Sharma, and this is my brief introduction. Am I audible, right?
Yes.
Yes, ma'am.
Okay, Nishant and Pinak. Okay, so I'm a PhD student and I had my MSc in Environment Management from Forest Research Institute and PhD in Botany Honors from University of Delhi. And because I'm a PMRF scholar, so that's why I have responsibility to teach. So I opted for this NPTEL to teach. And we will start with the MCQs, and I have some explanation slide for this MCQs, and we will try to discuss all the MCQs, and we'll try to find out the correct option that is correct. And your participation is highly valued, right? Okay, so because this is week 5, and in last week we talked about something. We talked little bit about this invention inventory, and here we will talk about like different type of emission inventory. For example, transport emission inventory, then for the industrial sector, for the agricultural sector, for the residential and commercial sectors, and some application of the remote sensing. We will also try to uh, understand. Okay, so let's start with some MCQ. So I have first question. This is because all topic is related to the emission scenario. So that's why I put my first question related to emission scenario itself. So I have three statement and I want to ask which statement or which statements are correct. So I have three statements. The first statement, an emissions inventory of a given region for a specific time period is a comprehensive stock of all the pollution emitting sources. The second statement is it cannot be utilized for the development of pollution control strategies. And the third statement is emission inventory data can be regarded as an index for evaluating change in economic activities. So, and I have four options. One only, second only, first and third, and all of the above. So can you people write in the chat box which one is the correct option, or even you can speak. Okay, Pinak gave me the answer C. I'm giving you time because I think this
Ma'am,
question.
because first
Yeah.
one is talking about emission inventory. It's a definition that it is the comprehensive stock. It's right. And second, it is written that it cannot be utilized.
Mm-hmm.
So it is wrong. And the third one is also right. So answer will be C, according to
Okay.
me.
Okay. So according to you, the answer is C, and I'm expecting more answer from Alka, uh from Keithana or some. Can you people also give me the answer for this? Alka gave me answer maybe C. Okay. Okay. Uh, Okay, so yes, Pinak, the answer is C. And we also discussed about this invention inventory, and I have few slides from the previous week for this invention inventory so that we can move on to the different type of emission inventory. And that's why I put this first MCQ related to the emission inventory. So exactly the first was the definition. So what is the definition? Like this is nothing, but this is the just for example, if you want to collect the data for the emission. Okay, so for example, if you are running a vehicle, so how much emission it is emitting, a particular vehicle. For example, you are cooking, so what type of gas it is emitting for a particular area, for a particular time period, and not even a single gas. It may release, like if you are doing the cooking, it can release carbon dioxide, it can release carbon monoxide, it may even release nitrogen dioxide. So for different gases, activity is cooking. So for the cooking, you are emitting different gases For a, let's say, for rural area, or let's say for your household, and for example you are you are collecting this data for the 1 year. So you are what you are doing, you are just generating the emission inventory, let's say for the carbon dioxide, for the cooking activity, for let's say 1 year. Okay, so this is like that. So this is the definition. So this is particularly for a given region. It may it will obviously vary from one region to another region. For example, the one region is Delhi and second is Agra. Maybe in Agra, because of some factories, the sulfur dioxide is higher, but as like in Delhi, because there is a lot of vehicles, so you can say like nitrogen dioxide is higher in the Delhi. Okay, so this is invention inventory is for a particular area. Okay, so this is for particular reason and for a specific time period. Specific time period means for example, if you know that initially we had the BS4 stage, Bharat stage 4, and now all the vehicle we have the policy to implement this Bharat stage 6. Okay, so with this 6, there is a some kind of technology improvement from previous years to the newer vehicle. So what will happen? Some emission may reduce, some emission may higher after this type of policies that we implemented in our state or in our country. So this will vary. Like initially it was BS4, so that's why emission inventory may have some different value, and right now we are implementing BS6 in our state, country, or let's say city. Then invention inventory will be different for the different time period. So it is for a given region, it is for a specific time period, and this is what, this is the stock of all the pollution emitting sources. For example, vehicle, industries, power plant, road dust, construction dust, and residential. Like there are lots of activity that we can't count, but what will we do? You have a list of activities, then you will calculate how much pollution that particular activity is giving you, and you are maintaining that record, so that will be known as the emission inventory. So this was the first statement, and this obviously this first statement is correct. Okay, second, this is the this is the simpler definition. Like this is the estimation of the amount of pollutant emitted into the atmosphere. Then who will develop this? So some agencies, for example, in India, CPCB can create such kind of emission inventory. Then SPCB, that is the State Pollution Control Board, and even some industries itself can create the emission inventory, so that they can check how much innovative technology they are adapting with the time, so that they can say that yes, we are implementing, we are improving, and we are within our target emission. So that's why some industry itself can create this emission inventory. Then characteristics, we have a different type of activities that will cause the emission. So having the list of the activities is the one of the characteristics of this emission inventory. Then the physical and the chemical identity of the pollutant included. For example, uh, if we are calculating the vehicular emission, then in the vehicular emission you will see what value we have for the carbon monoxide, for the sulfur dioxide, for the nitrogen dioxide. So we have a different identity of the pollutant, and it may be like physical identity or the chemical identity. Then the geographic location, with a like I gave you the example of this Agra and Delhi. uh, Different location may have the, and obviously will have the different emission inventory. Then the time period we already have discussed. So these are the characteristics of the emission inventory. This is the one example where you can see the emission inventory of the particular vehicle type. So if you have car, if you have like uh, light duty vehicle, if you have high duty vehicle, if you have bus, then different type of vehicle will emit different type of gases, and the concentration will be different. Okay, so whenever we will create the inventory, we have to consider different type of vehicle, different type of gases, even the driving pattern of the person, even the geography of that area. That that will give you some different value for the emission inventory. So this is the one of the example for that. Then okay, so I talked about the emission inventory of the transport, but there may be like different type of emission inventory. For example, this may be for the agriculture. Let's say here we can see our carbon dioxide equivalent in million ton. So we can see like different sector is giving you the different emission of the carbon dioxide. Okay, so different sector means we are talking about different type of emission inventory. For example, for the agriculture, we created or generated emission inventory. For residential, created a different emission inventory. So likewise, we have a variety of the activity. Based on that, we divided our emission inventory into different parts. So here we can see the different proportion uh, of the carbon dioxide released into the atmosphere by different type of sectors. Okay, so and we will focus on this agricultural, residential, commercial, and the industrial emission inventory in the next slides. Okay, this I think I should not go inside it, but this is the example of how because we talked about that for a specific time period. For that specific time period, different different sector will have the different emission inventory. For example, you can see in the electric power. In the electric power, initially in 2000, it was higher, but as the time is going on, in 2020, the electric power generated carbon dioxide has been reduced. So this is the characteristics feature of that emission scenario. This is nothing but this is the, it varies with the time. So that's why we have to calculate it time to time. Then this is how this invention inventory is helpful for us. Why we are creating this type of invention inventories. So for example, in the climate change, our CO2 is increasing or the greenhouse gas is increasing. So after creating such type of emission inventory, we can see what type of effect we have of the climate change on different type of emissions, right? Then it may have the effect, it may have the impact on the health. For example, if the particulate matter is increasing over the time, then obviously the life expectancy can be reduced. Then the ecometric studies, for example, if we are talking about the GDP, as the GDP increases, it is said that our technology will also be improved. So either your if this technology will improve, then your emission inventory must have the lower values, and by which you can indirectly relate with this with your economy of that country. So likewise, you have different for the policy making. For example, if you want to create such type of machinery that can reduce your emissions, so what will you do? You must have some values. Based on that, you can say that after my that machine, after my that instrument implementation, the emission has been reduced. So you must have some kind of baseline values. So that's why these are the different ways, these are the different advantages of having this emission inventory in our state or in our countries. This is nothing but this is just like the previous slide. And okay, invention inventory may have the different type of uses. For example, if you want to see whether our greenhouse gases is increasing or not, then we will create such an invention inventory in which we will just focus on the gases, greenhouse gases. If you want to see the impact of the heavy metals on the human body, then in which you will just focus on this heavy metals. So likewise, like based on your need, you can create your emission inventory for that particular type of pollutant. Like um, if you want to see the ozone precursor, then obviously you will study, you will create that invention inventory for the nitrogen oxides and the sulfur dioxides. So likewise, if you want to see the impact of the particulate matter, then obviously you will measure that particulate matter emitted from different activities. Okay, so okay, we have two type of approaches by which we can study or we can create this emission inventory. The first is the bottom up approach. Means you will go to that site, you will install some kind of sensors, and then you will get some values. Okay, so you have to install everywhere some sensor, you have to do some kind of experiments, and you have to set up a lot of things to get this invention inventory. And this is nothing, this is the bottom approach. The second is top down approach. Means with the satellite, the emission has been happened already, and then you will try to track the source of that emission. You already have the emission, and from that emission you are going back to that source from where this emission is coming up. So such type of approach is top down approach. And the accurate one is the bottom up approach, because here we are we are estimating or we are calculating these emissions using the sensors. Okay, using so many instruments. But in the top down approach, we have to estimate a lot of things to track down the source. So that's why bottom up approach is more accurate. The crux of all the slide is that whenever we are estimating the emissions, so this will be the multiplication of the emission factor and the activities. So for example, if you are cooking, so while cooking, how many hours you cooked, and which type of gas it is releasing, and for that particular cooking activity, let's say for the 1 hour, how much emission you have. So you will multiply with the number of hours you cook. So activity data and the emission factor. So likewise, whenever you are talking about transport sector emission inventory or the commercial, so every time this will be the crux. What is it? This is the emission factor that will be multiplied by the activity data. So this is all about the emission inventory. So okay, so let's talk about the agricultural invention inventory. So I have one question. This question is: livestock enteric fermentation and rice cultivation mainly contribute to the formation of, I have four options: carbon dioxide, methane, nitrous oxide, and sulfuric acid. Nishant gave me answer B, that is methane. Okay. Alka gave me answer B, methane. Okay, if you two people gave me answer B, then it should be B. Okay, so here we have three terminology. The first is livestock enteric fermentation. So what do you mean by enteric? What do you mean by fermentation? And third, what do you mean by the rice cultivation, and how this rice cultivation can give you the methane production? So let's talk about it. Okay, so this is just fifth or sixth class definition of the fermentation. So fermentation is nothing. You have sugar, for example, glucose, and this glucose will be breakdown, and this will give you ethanol and the carbon dioxide. So the thing you have to see here is that glucose has been breaked down in the absence of the oxygen. There is no oxygen. So this is nothing but the fermentation. If you people know how we, whenever we respire or we inhale the oxygen, so what is the use of this oxygen in our body? So this is nothing but we have glucose because we have taken the food inside our body. We have food, we will take the oxygen. This oxygen will break this glucose and will give you the energy. Okay, and the side product will be carbon dioxide and water. Okay, but this is the respiration, and this is aerobic respiration. Aerobic means with the presence of oxygen, glucose is being breaking down. Okay, and this is giving you the carbon dioxide. That's why we are exhaling carbon dioxide and plus some water. So we are doing the aerobic respiration. Fermentation is opposite to that. This is the breakdown of the glucose in the absence of the oxygen. If we don't have the oxygen, then this will break down into some acid, for example in ethanol, and it will give you the carbon dioxide as well. It can also give you the methane. So that is the anaerobic, means no, in the absence of the oxygen. So fermentation is nothing. uh, this is converting the sugar into alcohol and the carbon dioxide. Okay, so from that statement, you already have known about what do you mean by the fermentation. And there are some role of the fermentation in our life. For example, whenever you are talking about wine or some kind of drink, then this is the product of the fermentation of the sugar cane, let's say, that will give you the whiskey or some other type of drink. Okay, then lactic acid or the carbon dioxide that has been like if you are using the baking soda, and that will give you the bread. So here we have the process that is the fermentation. Then so if we are doing the fermentation, if we are not doing the fermentation, we human being, but if you know that sometime because of some excessive exercises, our muscles may have the absence of the oxygen. So we also do some kind of anaerobic respiration, and that's why your muscle may have some kind of pain because of the accumulation of some acids in your muscles, because whenever you are excessive running, so because of some scarcity of the oxygen in your body, you may have some kind of pain as well. But let's keep it aside. We are talking about the enteric fermentation right now. So this is the digestive process by which carbohydrates are broken down by the microorganism. So in our human body, our carbohydrate has been broken down by some kind of enzymes and in the presence of the oxygen. But if we are talking about the animals, then this carbon dioxide is breaking down with the help of microorganism and in the absence of the oxygen. Okay, so this is the enteric fermentation. And if it is not oxygen, then this will give you the methane production. So here you can see that this is a cow, and whenever sugar is breaking down into the carbohydrate and carbohydrate into some kind of carbon dioxide, and it will also give you the methane because this is the fermentation. Okay, so so that's why most of the cattle may contribute to the methane production. Okay, then here we have the terminology rumen as well. So rumen is nothing but our stomach is monochambered, means we have uh, one whole chamber of that stomach. But in the cow or animal, they have the multi-chambered stomach. So because of that, they have the capability even to digest cellulose. For example, if we are eating the grass, we can't digest the grass directly because our stomach is monochambered. But because animals have the multi-chambered stomach, so that's why they can also digest the grasses directly. So that's why these are the rumen. Okay, so this is all about the enteric fermentation. Then let's talk about the rice cultivation. What happened? Why the rice cultivation uh, gives you the methane? So this is nothing but because of the excessive water, the pores of the soil get clogged. Means you don't have the like your spores is not void. Your spore has been, the soil spores has been filled with water, and that's why the organisms that are inside your soil may not able to have this oxygen from the atmosphere. So what they will do, they will have the anaerobic respiration, or let's say the means they will survive in the absence of oxygen. And if it is not oxygen, then again organism will release methane in spite of that carbon dioxide. Okay, so and in spite of hydrogen, they may also give you the hydrogen sulfide and so many gases that may dangerous to you. So that's why rice cultivation is also responsible for the contribution of the methane. So I think this is clear. Uh, okay. And why we are talking about the methane? Because the potential of methane is approximately 28 times more as comparison to the carbon dioxide. So it is equivalent to the 28 molecules of the carbon dioxide. And if we are talking about the nitrous oxide, the next question is about the nitrous oxide. So this is like 265 molecules. It is equal to 265 molecules of the carbon dioxide. So you can think about it, how much powerful greenhouse these methane and nitrous oxides are. Okay, next question is fertilizer and agriculture soil contribute to. So I have four options.
Nitrous oxide and ammonia.
Okay, Pinak gave me already some answer, but I'm expecting some other answer from some other people. Okay, so I have four options: carbon dioxide, arsenic, nitrous oxide, and ammonia, and the sulfuric acid. Pinak already gave me answer C. I'm expecting more answers. You can relate the fertilizer, which kind of compound you use in the fertilizer. So based on that, you can give the answer to me.
Because nitrous oxide is obtained from the treatment of manure generally. So fertilizer and agricultural soil is C1, nitrous oxide and ammonia.
Yes. So answer should be nitrous oxide and ammonia. And as you people know that in the fertilizer, most of the time your fertilizer is urea. You know, so urea is nothing but the compound of the nitrogen, and most of the time in our soil there is a deficiency of three compounds. The first is nitrogen, the second is phosphorus, and third is potassium. So NPK. So whenever there is a deficiency of this NPK, then you have to bring some kind of fertilizer that have that compound, and so you will do the spray in your field so that your soil may have this three type of compounds. So the one important is nitrogen. So whenever from that urea or some different sources we have, from where we will this nitrogen in different forms will release in the atmosphere. Let's say even through the groundwater mix with the mix with this nitrogen compound that you have given into your soil. So after that mixing, that will make some different compound that will be released into the atmosphere. So add even the ammonia. So let's say, I think I have one slide about this. Okay, so here you can see that manure storage, livestock, because of the urine, because of the feces, in that urine as well, there is a lot of nitrogen. Okay, and even whenever you are applying the fertilizer to your land, so that will also give you the nitrogen. That nitrogen will leach into your soil, and then whenever it will mix with your groundwater, and then it will give you some different type of inorganic type of nitrogen into your atmosphere. So I think I also have one more slide. Uh, Okay, so whenever you are giving the fertilizer to your soil, then this will give you the nitrogen dioxide or the species of the nitrogen. Then it will also give you the ammonia, that is NH3. And it can also give you the nitrous oxide. Nitrous oxide is also the product when some microorganism in the soil respire. So, and I already have talked about the global warming potential of that greenhouse gas, for example, nitrous oxide and the methane. And this is ammonia. Ammonia is not the greenhouse gas, but yes, if it will be the in atmosphere, it can create some kind of aerosols, in organic aerosol into your atmosphere after it will react with some kind of uh, pollutant. For example, if ammonia reacts with sulfur dioxide, then it will give you the inorganic aerosol into the atmosphere. And you people already know that aerosol have directly and indirectly impact on the atmosphere scattering efficiency, even the hydrological cycle. So uh, even on the how much radiation you will get on the surface. So so most of the things is dependent on the aerosol that we have in our atmosphere. For example, even the cloud condensation nuclei that will forms the cloud. So this that also need the aerosol. So alter the balance of the aerosol that we have before and that we will have after it. So such kind of impact may have after this ammonia that will be released into the atmosphere. Then okay, this is another where we can see, like, whenever you are talking about the fertilizers, then there should be in mind that this is the organic nitrogen. Okay, then this organic nitrogen will mix with the groundwater. There will be denitrification. Denitrification means the oxygen part will be removed by some kind of bacteria, and then it will release the inorganic nitrogen into your atmosphere. And whenever there is a more fertilizer, more inorganic nitrogen will be released into your atmosphere, and whatever the proportion you had into your atmosphere of the nitrogen, that will be disturbed. This is again after the after uh, whenever you are doing farming, then this may release the ammonia. This ammonia will released into the atmosphere. This may react with some kind of particulate matter, and then it may also impact the human health. Okay. This is the list of the pollutant that are being emitted by the agriculture. The ammonia that is from livestock farming, management, mineral fertilizer application, and even the particulate matter from the burning of the agriculture residue, the soil cultivation from crushing of bedding material by the movement of livestock, and the agricultural machinery. Then if we are talking about the nitrogen oxide, then because of the fertilizer this is happening. And if we are talking about the volatile organic compound, so this is because of the burning of our crops, or let's say the agriculture residue. Then because of some different type of processes that we have in the vegetation, that may also release some volatile organic compounds in our atmosphere. Then the gases that are released are the methane, we already talked about, nitrous oxide we already talked about, and carbon dioxide. Carbon dioxide is not that harmful uh, uh, than this methane and nitrous oxide. But yes, if carbon dioxide is in larger quantity, then obviously it will have a huge impact on your climate. Then uh, whenever you are calculating how much emission you have from the agricultural activities, then there are a list of the activities by which there will be emission of, let's say, greenhouse gas or the different pollutant. For example, we talked about the anthrax fermentation. Because of that, methane will release. if you are talking about the farm operation, for example, irrigation, tillage, and sowing. So because of that, some different type of gases or pollutant will be released. So how much gases, pollutants, or the or different type of pollutants are emitting by different activities, so you have to calculate it using some kind of formulas. And after that, you will create your invention emission inventory for the agricultural sector. So I have some formulas for that. For example, if you want to calculate how much methane has been produced by the animals or the cattle, so how will you calculate? Because different organism may have different capacity of releasing the methane. Okay, so here if you see that this emission is the summation of number of animals, and this is J is nothing but the different type of animals. So for example, if it is a cow, so how much cow we have, and the emission factor of this cow. And then let's say the next is buffalo, so how much buffalo we have for that particular reason, and what is the emission factor, how much it is releasing per animal. So likewise you can calculate this emission methane. Then if you want to calculate the emission of the ammonia or the nitrous oxide, then this is also like this: summation of number of animals, and J means different type of animals, multiplication by nitrogen excretion, and multiply by here the emission factor. Then if you want to calculate how much emission you have because of the irrigation, so you have to see, for that irrigation you need water. To extract that water from the groundwater, you need the electricity, or this electricity may come from the fossil fuel, from burning of the coal, for example. Then you will calculate it by how much amount you extracted from the groundwater, then what is the depth of this groundwater, then the efficiency of your pump to extract this, and then power loss in transmission. So likewise you can calculate how much carbon will be emitted whenever you will do the irrigation in your farm area. Another is tillage. So tillage is uh, for uh, for for how much time your tractor was operated in your field, and for that tractor how much diesel it consumed, and per hour how much diesel we use. So this is the emission factor. So likewise, if you want to calculate how much emission of let's say carbon we have because of the pesticide, or let's say the fungicide, so you will calculate how much fungicide or herbicide or insecticide you use, and that will be multiplied by the emission factor. Okay, so how much carbon it release per kg of the herbicide, so this is the emission factor, let's say. Likewise we have different formulas. For example, if you are applying the fertilizer in your field, so how much urea you applied, how much nitrogen you applied by DAP. This is the different compound of the fertilizer. Then how much P2O5 you applied. Then how much amount of K2O applied. So and this SSP and MO, these are the compound by which you have this K2O and this P2O5, and you will multiply each this amount with your the emission factor. Then you will calculate how much emission you had by the fertilizer.
Um,
Then yes.
Means whatever the formulas of estimating emissions, all are containing activity data into emission factor, right?
What please ask once again.
So whatever the formulas of estimating emissions, all are containing activity data
Yes.
multiplied by emission factor.
Yes, exactly. That's why in the previous slide I talked about this. Now you must have the list of the activity. Then that activity, how much pollutant it is emitting. So and you have to multiply it with the emission factor. Means for example, if you are running your vehicle on the road, so for example it is giving you the nitrogen dioxide. So per kilometer, how much nitrogen oxide it is releasing into your atmosphere. So you will multiply by your emission factor. So and how many car you have on the road, so how many hours there were car on the road, so such type of things will be multiplied and will give you the emission. So this is very simple thing. Okay.
Ma'am, how is the value of emission factor decided?
Emission factor is, I told you now, let me show you. So here, okay, uh, let's have the very simple formula. This emission of this methane, and this is the summation of the number of animals, and here J is the type of animal, and this emission factor of this uh, methane. For example, you know that for cow, for 1 hour, let's say it will release a methane, uh, let's say 20 microgram. Okay, 20 microgram. Then you have then you want to calculate it for 35 days. Then it will multiply by 3, sorry, you want to calculate it for the 1 year, then this will be multiplied by 365 days. And whenever you want to calculate it, let's say for the 100 cows, then it will be multiplied by 100. So emission factor is nothing but this is the amount that has been released by per raw material. So this is like per kilometer how much emission you had. And if you want to calculate for, let's say, 365 days, then you will multiply it with the 365. So this is like per unit thing. Did
Yes,
you
ma'am.
get it?
Yes, ma'am.
Okay. uh then this is very important if you are doing the residue burning in your agricultural area. So how much emission you had after this open burning of the agricultural residue. So here this is the broad formula in which they also calculated it for the country level, or let's say the state level. So S1 is the state, D is the district, and C is your city. Okay, so this is, let's say, for the one city of one state, or of one district of one state, and then you will multiply your total production of the particular crop. So for example, in that 1 hectare of the field, you had 100 kg of crop. Okay, but that 100 kg will not give you the uh, of that 100 kg, only the organic matter in it will give you the residue burning. Okay, so you will see how much dry matter you have in that 100 kg of your particular crop. So this will be FDA. Then this RE is the fraction of residue generated for the production, and this FBA is combustion efficiency. For example, if it is a wheat, then the combustion efficiency of that wheat will be different from the rice. So this will also be multiplied, and at last we have the emission factor of the particular pollutant. So here by this unit you can estimate. What do you mean by the emission factor? This is like gram per kg. So per kg of the crop, how many gram of that pollutant you are releasing. So this is the emission factor. So by which you can calculate how much pollutant you are releasing because of that uh, residue burning or the agricultural burning, right? Okay, so that was how you can calculate your emission inventory for the agriculture. And we have some kind of tools for the agricultural emission calculation. So next question is related to that. Which of the following is or are the tools to calculate the agricultural emission? So we have option SIT, SIT, Agri, Gleam I, ACA. So I want to see which one is the correct answer? Nishant gave me D answer. Tomato, ma'am, please send no. I can't do this. Okay.
Ma'am, D
So,
will be the answer because SIT means the state inventory tool,
mhm.
and Gleam one is related to livestock, so it is also related to agriculture emission. And ACES means it's like related to greenhouse gas.
Okay. So, the answer should be D. Exactly. Nishan gave me right answer. So, why do we need these kind of tools? So, so I give you one example. Here you can see that we used that formula, but every time it is not very easy to calculate emission inventory by using such kind of formula. It can be very complex because we have state, we have city, we have different kind of population, we have different type of crops, we have there may be a lot of factors that are affecting such kind of emissions. For example, your topography is affecting your emission factor, or let's say your climate, because of the different level of humidity, different level of temperature, you may have different emissions. Okay, so this is not that much easy to calculate these emission factors, or emission inventory by these kind of simpler formulas. So you must have some kind of models. That model may have the embedded calculation, mathematical calculation. You will give some kind of inputs. That input will be related to your emission factor, your activities. After that, that model will calculate your emission inventory. Okay, so that's why we need that type of models or that type of tools. And different model have different advantages and disadvantages. So here, because these are the four different tools that we can use for the agricultural emission calculation, and not even four, we have 1,000 of such tools by which we can calculate this agricultural emission. And the full form is this. If you are talking about SIT, Pinkle gave me the full form of this SIT, that is the state inventory tool, and in which we have one module, that is the agricultural module. I will show you what kind of input we need for that kind of tool. Then we have the agri tool, that is the agricultural emission estimation tool. Then we have GLEMI and the ACE. So we will talk only about this this first one, because okay, Pinak. Sorry for pronunciation. So this is SIT model. So we need some input, some data requirements. So let's say for the enteric fermentation, the data you need is emission factor by animal types and animal population number. So there should be the input data of that enteric fermentation like this. For example, for manure management, you need typical animal mass, you need volatile solid productions, maximum potential of methane emission, then vegetable nitrogen excreted, and the animal population number. So such kind of data you need, you will fit that data into your model, and your model will give you the amount of gases that will be released by such kind of activities. So methane, nitrogen, nitrous oxide, so such kind of gases. uh, so this will be the output. So here you can see that this AG module calculate carbon dioxide, methane, nitrous oxide emission from the agricultural sectors from the sources that have been given into your table. So this is giving you just three type of gases, and these are the greenhouse gases. This is not giving you different pollutant, for example particulate matter. Some tool may give you particulate matter, some tool may give you the sulfur dioxide or the nitrogen dioxide emission inventory, but this particular tool will give you the carbon dioxide, methane, and the nitrous oxide. And before that, you have to give the input like that. Uh, Okay, I have one, I think, slide for this gleam eye as well. So in that gleam eye, the input is, we can, so this is the global coverage of 6 livestock species, means more, not more than 6 species. You can't, you can't do, you can't give the input to your tool more than 6 species of that livestock, for example. So, and these species are listed within that model. And then how much edible products they are producing from that species. For example, it is giving you the milk, it is giving you the meat. So, and even after producing that milk or meat, uh, what will be the emission after consuming it. So such kind of things can be, uh, 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 like, there are input of the species, then the products you may have from that species, and then they will calculate the greenhouse gas emission from each stage of the production, and it will give you the methane, carbon dioxide, and nitrous oxide using an IPCC methodology. So this will give you only the greenhouse gases. Okay. Next question is, I think we already have seen this formula. So which of the following equation is used to estimate the methane emission from enteric fermentation? A, B, C, D. This is very easy. Alka, can you guess?
And multiply.
Okay, so Nishant gave me 3. Okay, yes. So obviously, this is EF is the emission factor of the methane, and you will multiply your emission factor with number of animals of that particular animal type. Okay, and then you will do the summation for the different type of animals you have. Then you will get the emission methane. So obviously, third is the right answer. Okay, so that was about your in emission inventory for the agricultural sector. So now let's come to the transport emission inventory. I have one question. The factor that need to be considered while calculating the transport inventories are, so I have options: vehicle type, fuel category, vehicle kilometer travel, driving behavior, and I have options: first and third, second and fourth, all of the above. Oh, above spelling is mistakenly wrong. Anyway, so what should be the answer?
The answer should be first and third. Vehicle type and vehicle kilometer traveled.
Okay. Any other guesses? Alka gave me answer C, second and fourth. No, answer should be actually D. Why D? I tell you. Uh, okay, answer
Yes,
D.
ma'am. I thought that answer is D, but then I thought that driving behavior can't be included.
Okay, so for example, someone is driving, someone is giving the brake every minute. Okay, so he or she is pressing the brake every minute. That will give the emission of some particular gas different as comparison to the one person that is not pressing the brake, uh, brake every minute. So this is the driving behavior. And some, okay, it's all right,
Ma'am,
Alka.
but the statement you are saying is not a major problem now. If we
Ah,
regulate the rules,
no, this is also the major problem. This is only the one thing that one person have the different driving pattern in the relation of brake pressing. Second is the speed. Some may like to have a very high speed, some may like to drive very slowly, and you people already know that driving slowly and driving very fast, may have different emission, and even the consumption of your petrol and diesel will vary according to your speed of the driving. Okay, and this is like, if it is for the one vehicle, then it is okay, this is negligible. But we have the crores of vehicle on our road, and different driving pattern may have different type of emission pattern as well. So that's why this driving behavior is also important. And no doubt in India we don't have such kind of data, but in USA, in Europe, we have models. In that model, this driving pattern or this driving behavior is one of the important input. Because of that also, uh, like because of that, there is a lot of policy in the USA, that you have to drive in that speed, you don't have to this and this. And uh, this driving pattern have a huge impact on this emission, the emission of nitrogen dioxide. If you people know that, whenever your diesel is burning or a petroleum is burning, so the temperature at that time will decide your emission, the amount of emissions. That's why this driving behavior is also important. Then this vehicle type, whether your vehicle is just the two-wheeler, or it is just the four-wheeler, or it is the light duty vehicle, it is the heavy duty vehicle. With different vehicle, your emission will be different. If we are talking about the fuel category, then it is a CNG dependent, or it is a petroleum dependent, or it is a
or a
diesel.
hybrid.
So based on that, your emission will be different. Then the vehicle kilometer travel, either your vehicle is traveling 1 kilometer or 2 kilometer or 3 kilometer or thousands of kilometers. So this will also give you the variation in your transport inventory. And I already talked about this behavior, driving behavior. So these are the four factors that will decide or determine your emission inventory. uh, and okay, so this is the one figure that I want to show, that whenever there is the vehicle on the road, so different type of emission may happen because of that road, not just because of the fuel combustion. So if it is a fuel combustion, then this will give you the exhaust emission. This may be carbon dioxide, this may be carbon monoxide, hydrocarbons, nitrogen oxides, particulate matters. But beside that, whenever you are refueling, um, at that time, some of your fuel may evaporate. Okay, then and even may fall down. So this will give you the refueling loss. For example, hydrocarbon and volatile organic compound. Then cooling evaporative emissions. Because of the evaporation of your fuel, this may also release some of your pollutant into the atmosphere. Then because your tire is striking with the road, then this will give you the particulate matter that has been generated from the road, and as well as that has been generated from tires. And this will also give you the particulate matters. So by these different ways, your vehicle may give you the variety of pollutants. Then if we are talking about the vehicular emission inventory, then this is the important tool for assessing the vehicular emission based on the emission factors. These are and then average speed, fuel consumption, and the amount of traffic on the defined road type. And you can develop it manually as well as the computer based. Right now, the researchers are working very hard to make it as a computer based vehicle emission model. Then there are factors. We already talked about this: vehicle type, then fuel category, vehicle kilometer traveled, emission standard, and various correction factors. Then this is the model I already talked about. We need some input. Then model have some kind of equations that are embedded in it. Then after that, like whenever you will give the input to that model, this will give you the output. So after giving that input data, for example, how much vehicle you have on the road, what different type of vehicles you have, what is the age of that vehicle, what is the technology that you have in that particular vehicle, and such type of inputs will give you the output. For example, vehicle emission inventory by pollutant. So let's say for the carbon monoxide, different type of vehicles, different type of diesel will give you the different values. So such type of things, this kind of emission model can give you. Then vehicle type contribution. Um, for example, if it is a four-wheeler, then how much pollutant it is releasing into the atmosphere. If it is let's say two-wheeler vehicle, then what is the percentage contribution of that particular type of vehicle for the emission. So such kind of data you can have after giving your data to the model. Okay, the next question is, there is a one model, the name of that model is mobile, and where we have some formula, and this formula is the hot running emission per unit distance. And so you have to tell me which formula is correct, A, B, C, D. Can you guess which formula is correct? Okay, so A answer is right. We will see this. Okay, so as I told you, we have different type of models for calculating the emissions inventory for a different sector. So if we are talking about the vehicular emission inventory, so we have lots of model. For example, we have divided these models into three types: the average speed model, the instantaneous speed model, then the multi-scale model. And in that average speed model, the one model is mobile. uh, we have EMFAC, we have COPERT 4, and so we have under this average speed model, under this instantaneous and the multi-scale model. And because our question was related to the mobile model, so let's talk about this. So mobile model compute the hot running emission of per unit distance in freeway or arterial as a function of travel speed for 5 miles per hour speed increment. And there is the formula here. Ex is the emission in per unit distance. Then SPF is the speed correction factor. BER is the basic emission rate, and O is emission offset. And I can't tell you exactly from where this formula generated, because like there is a lot of studies and there is a lot of calculation that has been done before forwarding this formula to us. So, but yes, this is the formula that we have to compute this hot running emission of per unit distance, right? So answer should be this one. Okay, next, which of the following limitations is or are associated with the IMPA? So this is another model, that is vehicular emission inventory model, and we have to tell the limitation of that model. So we have three options. It doesn't include the dynamic behavior of the engine. Inclusion of a catalyst model should lead to the improvement in the existing model, and it has been developed only for light duty vehicles. So which should be the right answer? A, B, C, D. Okay, Pinnock gave me answer D. Okay, exactly answer should be D. Okay, answer should be D. And as I told you, like different models have different limitations, advantages. So if we are talking about this IMPA model, this is based on the mathematical model, means we have a lot of differential equations, and whenever we are solving these differential equations, then we will get some value of the emission. for a very short period time scale. Then but this have the some limitation. This limitation is it do not include the dynamic behavior of the engine. Whenever we are improving our engine, then that haven't considered into that model. Then the inclusion of catalyst model should lead to the improvement in the existing model. Yes, this is again right. And the third is the main disadvantage of this model is that it has been developed only for light duty vehicle. But right now in our road we have the heavy vehicle duty, we have vehicles, we have two-wheelers, we have four-wheeler, we have buses. So different type of vehicles we have on the road, and this is only for the light duty vehicle. Then obviously this will give you the disadvantage while you will use that EMPA. Okay, so we have covered this agricultural inventory. Then we have covered the transport emission inventory. Then the third is industrial emission inventory. So I have okay. So why do we need this emission inventory for the industrial sector? Because whenever we are manufacturing something, then we need energy. Okay, energy, and from where we will get that energy? That energy will be from the combustion of the fuel. For example, if you have some industry of the cloth, then you need machinery to run. From where this machinery will run, you need some kind of energy, and from where this energy will come? This energy will come again from the combustion of the fuels. Okay, if it is the if it is the like different plants we have. Yes, exactly, Pinak. Your whole engineering is all about energy and the design, and that's why. And from where this energy will come, and this energy will come from the combustion of fuel. And whenever there will be the combustion of fuel, that some kind of gases will be released into your atmosphere. So you will also have to calculate how much gases, how much pollutant you are releasing into the atmosphere from that particular activity related to your industries. Okay, so that's why we need the inventory for for the industries as well. And there are some factors that will affect your industry's emission. For example, if your industry is very at a very small scale, then this small scale industry may not have sufficient budget to buy a machine that may reduce the emission of that toxic chemical into your atmosphere. But a if it is a large scale industries, for example owned by Reliance, owned by Ambani, then they have enough money to buy such instruments or such machine that can treat your pollutant before releasing into the atmosphere. So how many large scale industries you have, how many small scale industries you have, so this will have impact on your emission inventory. Then use of outdated technology. If your industry is using the outdated technology, then it may release higher amount of pollutant as comparison to the innovative technology in the present if you are adopting. Then the lack of policy to control pollution. If you don't have policy in your state or country, then what will happen? uh, Without any discrimination, every type of pollutant they can release into the atmosphere. But if there is a policy that that much of pollutant should the amount of pollutant should not exceed to that much amount into your atmosphere by some policies, then obviously this will also affect your industry emission. Then insufficient waste disposal. Obviously, if your waste have for example waste is sulfur dioxide, okay, then this sulfur dioxide can be treated with the lime. Okay, and if you don't have the lime, then your waste will be disposed as it is, means sulfur dioxide will be released in the atmosphere as it is. And the next is unplanned industrial growth. So unplanned means you don't have any kind of plan of how to mitigate the pollution pollutant you are releasing in the atmosphere. You didn't install any type of machinery that can reduce the pollutant. But so this is the unplanned industrial growth, or maybe because of the competition, maybe because of the supply need, there may be unplanned industrial growth, and these are the factor on which this industrial emission will be dependent. That's why whenever we are formulating the formula to calculate our emissions inventory related to the industrial sector, then we have to consider all such things. How much mitigative the capacity we have for that particular industries, then what policy we have, so such kind of things. Okay, then if we are talking about the models for this for calculating the industrial emission inventory, then popular models are Markle and Gaines. Okay, and next question is related to Gaines only. Okay, so emission of which of the following air pollutant is not estimated by the Gaines model? So which type of air pollutant is not estimated by this? So I have four options: heavy metals, particulate matter, volatile organic compounds, and the ammonia. So what
Heavy
should we?
metals cannot heavy metals cannot be estimated. While
Okay,
PM can be calculated VOC2 and NH32.
okay. Any other suggestions? Nishant gave me first. Okay. Alka, what's your answer? Like we can't remember the characteristics of different models, but yes, like if it is a one or two model that are popularly used for such kind of calculation, then obviously we can remind that. But obviously I can understand that the characteristics feature of each and every model we can't remember. Then okay, so answer is first, that is heavy metal. So I have some slide for this gain model, one or two I think. So how this gains model work? So uh, gains estimate historic emission of major air pollutant. So these are the pollutants: sulfur dioxide, NOx, VOC, particulate matter, ammonia, and even it also estimate the greenhouse gases. For example, carbon dioxide, methane, and nitrous oxide, and the fluorine gases for each country based on data from International Energy and Industrial Statistics. Means some agency have some data of the past of the history, or this historical period is mainly from 1980 to 2005. Okay, so for that particular time period, that agency have the data that has been collected from different countries, and based on that, that model is giving you the data of the air pollutant and the greenhouse gases. Okay, then this gains estimates for each country and region the potential emission reduction that are offered by about 2000 specific emission control measures and their cost. This is nothing, this is just like that you have the past, or if you have the historic emissions, means you know that from 1980 to 2005 how much emission you had. Okay, then you have different option after that based on some mitigative options. For example, you are improving your engine. Okay, or you are having some kind of policy that can control some pollution. Okay, so you have different type of intervention. Based on that, if you will apply that intervention, that then your emission can be reduced. So you have such 2000 specific emission control measures. So you have to select which measure you can take in the future. And if you know that this kind of control measure we will take in the future by our country, then based on that, that model can give you the amount of that gas that will have in your future, and that can also give you the cost, how much cost you have to apply for such kind of control measures. Okay, so such kind of output these gain models give. Then so it has two mode. The first is scenario analysis mode, the second is optimization mode. So scenario mode means as I told you, you have different tabs. The one tab will be improving the engine. The second tab will be uh, a very stringent policy. The third tab will be uh, like the innovative. Uh, let's say innovative accelerator you have in the vehicle. So based on that, after selecting various options, that will give you the future emission. So this is the scenario analysis. The second is optimization mode. So this will identify where emission can be reduced most cost effectively. So you will give you this mode will give you by this mode, this is like you don't will have the option what type of strategies you have in the future, but it will just give you the emission whenever, like you will tell what type of how much cost you want to like you want to expand. So based on that, it will give you the emission and the emission. Then, okay, this question is again related to the gains. So here you have to tell me the full form of gains. So I have four option in which sorry, two words are similar: greenhouse gas and air pollution. And these are like another two words are different: information, simulation, interactions, synergies, and information and simulation. So what should be the full form of these games? A, B, C, D. Alka gave me answer C. Okay. B and C are same. No, B and C are not same. This is like one is air pollution and second is air pollutant. So you have to tell me whether it is air pollution or air pollutant, and then whether it is a interaction or the information, or it is a simulation or the synergies. Okay, so means your answer is B. Okay. Okay, so you gave me right answer. The answer is greenhouse gas and the air pollution interaction and the synergies. This is like I can give you the backup slide for this question because this is just the abbreviation and the full form of that. Okay, so this is greenhouse gas and air pollution interaction and the synergies model. And this grew out of rain. So initially it was the rain, and after that, m- after some improvement, it has been replaced by these gains. And this is the integrated assessment model that deal with the cost and potential for the air pollution control and greenhouse gas mitigation and assessing interaction between policies. Okay, so we have covered three type of emission inventories: agricultural, industrial, and the transportation. So the last one is residential and commercial emission inventory. So I have, okay. So we have different sectors. Yes, Rajbala, what query you have? About registration of exam, I think you can write to the NPTEL. I can share you the email ID of NPTEL because I don't know exact about this registration of exam. I didn't enroll, uh, so like it will be better if you are if you will mail to the NPTEL, so they can give you the exact information. Yes, I will share you with you, Rajwala, later.
Madam, hello.
Yes, yes, yes.
Hello, madam. I have submitted my two assignments,
Mhm.
but due to some circumstances, I was unable to submit more. So, can I register myself now and submit these assignments further?
See, I don't know about such things because like I don't know the NPTEL policies, but obviously I will give you the email ID of NPTEL so that you can have some information like that. I don't have
Okay,
such
madam.
information.
Okay, okay. Thank you, madam.
Thank you, Rajwala. Okay, so Alka gave me answer A. That is the commercial sector that will cover the emission from activities such as cooking, heating, captive power generation in hotel or offices, shopping malls, hospitals, and the crematoriums. Yes, answer is right. Commercial. We already have talked about agricultural, industrial, and transport, and we already know about that. And the next one was obviously the commercial, and in that commercial and residential. So if you are talking about the residential, then obviously this will include the domestic cooking and some use of fireplaces, uh, such as if you are using the household stoves, or let's say you are using the gas in your kitchen, then this will contribute to some kind of emissions. Okay, so if you are collecting the information regarding that, then that will be covered under this residential sector. But for the commercial sector, uh, sectors will cover such as cooking, heating, boiler operation, captive power generation in commercial sector such as hotel, offices, restaurant, shopping mall, hospital, and these facilities are available in urban area, no doubt, and that's why most of the commercial activities will be happened only in the urban areas, not in the rural areas. And the typical urban type of fuel combustion will be such as gaseous fuel, coal, oil, kerosene, etc. So, okay. So this was the basic list of the activity that we do under this commercial and the residential sector. And these are the different pollutant that are emitted from residential and commercial sector, such as particulate matter, black carbon, organic carbon, sulfur dioxide, carbon dioxide, oxide of nitrogens, then carbon monoxide, methane, and non-methane volatile organic compounds. So this is the list of the pollutants. So based on that list, based on our activity, we can create our emission inventory for the residential as well as for the commercial sectors. And the basic equation to calculate the residential emission, we have E. E is nothing but the emission of pollutant I. Non-methane means it is a no. I show you. Like we have the volatile organic compound are nothing that can evaporate very easily into our atmosphere and that are organic in nature. And such type of volatile organic compound is the methane as well, but we are excluding this methane because methane is the greenhouse gas and it is very important. So uh, one important pollutant is methane itself. So other than methane, we have the volatile organic compound that will be covered under this NMVOC. So this is non-methane. Means we are just excluding the methane out of the list of the volatile organic compounds. We have thousands of volatile organic compounds. So from that we are excluding our methane. Okay, so here is the basic formula. So if you want to calculate the emission of the pollutant I. So pollutant may be, let's say, carbon monoxide, it may be methane, it may be nitrogen oxide. So pollutant I means your pollutant will be changed from fuel type J. For example, if you are talking about coal, then the pollutant, then it will release carbon. Okay, most of the carbon. It will not release the sulfur dioxide or the nitrogen dioxide. But if we are talking about the kerosene, then it will give you different type of pollutant list and different proportion of that pollutant. So likewise, you will calculate the emission for different pollutant and for the different fuel type, and this will be the summation of FC, that is the consumption of fuel type J. So how much fuel you consumed, let's say for the cooking. For the cooking you are using, let's say, LPG. So how much LPG you used for your cooking, then the emission factor per kg of LPG, how much emission of that pollutant we have. Okay, for example, for 1 kg, let's say we have 10 gram of carbon are released. So this is the emission factor. So you will multiply your emission factor with the consumption of fuel type, and then the summation, and this summation is nothing, this is for the different type of pollutant. Then this you will sum up, and then you will get the residential emission. Likewise, if you want to calculate for the commercial emission, then this is again, here we have IJK. I is for pollutant, different type of pollutants we have. J means different type of fuels we have. K means different subsectors we have under this commercial emission. For example, in the hotels, we have different type of things in the, let's say, in the washing area, or washing or let's say you have malls have different malls can be considered as a different subsector. So for different subsector you have different fuel type, for that different fuel type different pollutant you have, and you will calculate by the summation of this, and you will multiply this with the emission factor. So this will be the basic equation for estimating your commercial emission. Then the question is, the general equation for calculating the emission from residential or commercial sector is the product of what? Population and emission factor, fuel consumption and emission factor, fuel consumption factor and duration, fuel consumption and population. So what should be right answer? We already have discussed in residential.
Consumption and emission factor.
Yeah, Rajpala, no, population, like each, like if we have 100 people, then 100 people will use some fuels, then we will multiply this population with the fuel consumption. Like fuel consumption will be calculated from the population, no? So let's say we have the 100 household have, let's say, in each household we have 5 members. So 100 into 5, then each member, how much fuel consumption is having, then this will be multiplied by this. So fuel consumption itself have the population data. So this fuel consumption multiplied by the emission factor, that will give you the emission inventory for the commercial as well as for the residential. So the B is right answer. Okay, so we have talked about the emission inventory. Then I have one or two questions for this remote sensing. This is very important. Okay, so I have one figure. In that figure, I have sensor at the position D, and then I have some towers and the processing, in which you have to tell me what do you mean by this B.
Like A here is energy source, so I think B is the radiation and the atmosphere.
Yes, answer is B. And yes, Rajpala and Alka gave me answer B. Obviously, if you will see, like, this is the principle of remote sensing. So what will happen at some surface, C? Okay, so C is the surface. At some surface, your solar energy or some energy will be emitted. Okay, so this energy will be emitted by the radiation. Okay, and this will transfer transfer within that atmosphere. Then this source will give you some energy at the point C. Thus, this energy will be sensed by some sensors. That sensor is way away from your surface. That's why it is
Ma'am,
remote. Yes.
can we call them as the receptor?
Yes, we can call it as the receptor, right? So, uh, yes, in the Pinker language, we have a source A. Then source A will receive some energy. Sorry, A will give you some energy at the receptor C, and then this energy will be sensed by the sensor D. Okay, then after this sensing by this sensor, and this sensor are in the satellites. Okay, and then based on the tower, because you have the towers, that tower will the energy, sorry, the information will be transferred from the D to E, and then the information you may have in your computer. So this is the remote sensing principle. Means there is some energy that is coming from outside. Even your satellite may also give you some energy. Then this energy will come up to the receptor. Then because receptor have some energy, this will be reflected back, and whenever it is reflecting back, then this reflecting back energy will be sensed by the sensors, and this will be the information that we will have in our computer after some kind of processing. So B is nothing. This is the radiation and the atmosphere. Okay, so we have two type of remote sensing. The first is active remote sensing, and second is passive remote sensing. Active remote sensing means the energy source is satellite itself. It is giving you the energy, is having the energy from the satellite itself, and then the reflected back energy is sensed by the satellite itself. Then this is the active remote sensing. Passive remote sensing means your energy source is sun. Then this will give you the energy to the receptor, and then reflected radiation will be sensed by your satellite. Then this is the passive remote sensing, and we have a lot of advantages over active remote sensing over passive. Because sometime if you want data for the night time, in the night time you don't have the sun, then what will happen? You will not have the information regarding some processes that are happening in the night time. So that's why we need our own energy source. So that's why active remote sensing is very important to have. Then this the principle of remote sensing is based on the radiation that has been emitted by the receptor. So what type of wavelength we have that has been emitted by that receptor? So based on the curve of the reflectance, the remote sensing will sense the information, will give you some kind of information. So for example, if you see, if there is a vegetation, then this will give you the different peaks in different electromagnetic radiation. uh, okay, Rajpala. Okay, so we have two type of remote sensing, the active and passive. Active, I show you in that figure. If you see, A, that is sun, is giving the energy at C, means at the receptor, and this energy will be reflected back, and this energy will be sensed by the sensor that is present in the satellite. If this energy is given by the sun, then this is known as the passive remote sensing. But because you know that at night time sun is not available, then what will happen in the night time? uh, the satellite itself will give you some energy at the receptor, and that then this energy or this light will be reflected back and will be sensed by the satellite. Then this will be the active remote sensing. Is it clear, Rajwala? Okay. So I told you like basic principle. So if you see that this vegetation have a very high reflectance in the near infrared radiation and very low reflectance in the intermediate infrared radiation. So based on the peak of absorption, or based on that we can have the information in our satellite data. So, and that we can exploit. Based on that we can tell a lot of things about our vegetation, about our soil. Let's say if you know that whenever there is a burning in the farming area, then this burning may have a different peak of this radiation, in spite like at one place there is a crop and another place there is a burning. Then this burning will give you the different signature of the electromagnetic radiation as comparison to the crop area. Okay, and that different signature of electromagnetic radiation will be sensed by our sensors, and that will give you the information that yes, there is the incidence of that fire. uh, you can tell me the question of current assignment, because it is not good for us to give you the exact answer of your correct assignment. But if you have some doubt regarding your current assignment, you can obviously can ask me. Okay, and there is a like this is the absorption percentage, how much how much absorptions we have for the different gases, and this is the property by which we classify our greenhouse gases. Greenhouse gases are doing what? They are absorbing our outgoing radiations. Okay, so means they are absorbing, they have some absorption peak. If they have absorption peak, then they will warm the surface of our earth. So and whenever there is a like there is the atmospheric window, means the absorption is zero. Okay, so means every radiation that has been emitted by our surface will be reflected back to the space. But some of the molecules of our greenhouse gas can absorb that light, and that can give you the warming effect, and that's why these are the greenhouse gas. So remote sensing is all about the absorption and transmittance of the different wavelength, and that are being sensed by your sensor, and that's why our remote sensing things are working very well. Okay, so what are the application of remote sensing in air quality management? So I have four options: monitoring of air quality data, validation of models, identification of airshed, and the demonstration of episodic pollution. So which one is the right answer? Tomato gave me A. Are you really the tomato? Tomato. Anyway, Pinnock gave me answer 4. Okay.
Ma'am, I just have one doubt.
You just
In the fourth option, it is written episodic pollution. I can't
yes.
understand it now.
Episodic pollution is like uh, for example, take the example of Delhi. In the winter time there is a always high percentage of the pollution. So this is the example of episodic pollution because of some meteorological condition. Like this is not the accidents that are happening, but after some interval there is a pollution because of some meteorological conditions and because of some topographic effect. So these such kind of pollution are the episodic pollution.
Yes, ma'am. I think it is in week six, ma'am. You are discussing week six, I think.
uh, it may be, I don't know, but this is the episodic pollution. Okay, Alka gave me answer D. Yes, the answer is D. Rajbala, you gave me answer B. No, we have the satellite that can monitor the air pollution. Like we have a lot of satellite and sensor that are giving the value of carbon monoxide, even the ozone concentration, the stratospheric ozone, the tropospheric ozone, even the nitrogen oxide, sulfur oxide, every kind of values we uh, can get from the remote sensing. So A will be the correct answer. Then fourth is the demonstration of episodic pollution. Uh, if you will see that in Delhi, there is a high level of aerosol in the atmosphere whenever there is the episodic pollution. So, and such kind of aerosols that are present in the atmosphere can be captured by the remote sensing. And the principle is, we will see this principle in the next slide, that if you will have aerosol into your atmosphere, then this light that are coming will be scattered, means your light intensity or the light amount will be reduced. So such reduction in the light can be measured by your remote sensing. So that's why that can also give you the data for this episodic pollution as well. So all the answers are right, and these are more application of remote sensing. You can even forecast your air quality. Then you can improve the characterization of surface level air pollution. Rajbala, in week 4, we discussed about this airshed. This airshed is nothing but a particular area of having a very similar kind of similar characteristics of the pollution. For example, Delhi may be one airshed, just like watershed. What was a watershed? Watershed is nothing, a river and the nearby area that have the specific characteristics. Likewise, airshed. Airshed means similar characteristics of pollutant you may have for a particular region. For example, for Delhi, uh, Delhi can be considered as a one airshed. For example, this is based on the administrative boundary. You can even classify this airshed based on the topography. For example, if there is a valley and there is a plain area, then you can call this plain area as a one airshed and this valley as the another airshed, because valley have different pollution level or different composition of the pollutant, but plain may have the different because of the topography. So airshed is nothing but a particular area that have a different similar characteristics of the pollutant. Then improvement of the emission inventory you can do, and then the incidental release monitoring. Like these are the some of the applications that you can exploit by this remote sensing. Okay, the next question is, which terminology express the quantity of light removed from beam by scattering or absorption by aerosol during its path through the atmosphere? Alka, give me answer C.
Ma'am,
Uh,
aerosol optical depth will be the answer.
huh. Yes. So C should be right answer. Aerosol optical depth. Note the aerosol optical dispersion. There is a definition. Okay, if we are talking about this optical depth, then this is the unitless quantity that relates to how much light it absorbed along its path. Means some aerosol will absorb some gases, and then some aerosol will absorb the light, and because of that because of the scattering, because of the absorption by this aerosol, your light intensity will be reduced. Okay, and such kind of things can be calculated using this optical depth. Then note that optical depth is greater at the initial position than at the final. So optical depth will decrease as photon move towards the observer. Then okay, so the concentration of particulate matter can be calculated if you have the value of aerosol optical depth by using that formula. So I'm not expanding the formula. You can see here. You just have to keep in your mind that a satellite is giving you the aerosol optical depth, and if satellite is giving you the aerosol optical depth, then you can calculate the concentration of particulate matter at that particular time in your atmosphere. Okay, there are some mixed question. Okay, so remote sensing part is done and different inventories we have covered. So there are some questions like, which is not the source of vehicular emission? Exhaust, evaporative, fuel storage, road surface tear. Nishant gave me
Storage.
C, Tomato gave me A. I think Nishant answer is right. That is fuel. Rajpala gave me answer D. Uh, road surface tear. Yes, the answer is C actually. So we already talked about it. Like uh, a, a vehicle by very different way can emit different gases. For example, by the exhaust emission. So exhaust emission is nothing after the combustion of your fuel. This will give you the exhaust emission. Evaporative emission, some of your fuel may evaporate somehow, then this will give you the evaporative emission. Road surface tear, whenever your tire is striking with the surface because of the friction force, because of the drag force, this can give you the particulate matter, this particulate matter from the tire and also from the surface, that can also give you the emission. But fuel storage is nothing, like this is not giving you the vehicular emission. So obviously answer C is the right one. Next, which is the major pollutant of the vehicular evaporative emission? Which is the major pollutant of vehicular evaporative emission? So Pinak gave me answer D, VOCs. Okay. Okay, thank you, Tomato. Answer should be D, because if we are talking about the evaporative, yes, Nishant, it is D. If we are talking about the evaporative, means uh, your compound should evaporate very easily. So we have volatile organic compound that evaporates very easily. Then uh, uh, then this VOCs will be the right answer. Sulfur dioxide, nitrogen dioxide, and ozones cannot evaporate very easily. That's why you will found it very near to your surface. But if you are talking about the VOCs, that can be found at some height and they can evaporate very easily. That's why this VOCs will be the right answer. Okay, do the climate and geography regulate the vehicular emission? Yes, no, both, maybe because of insufficient evidences. So what do you think? A, B, C, D. Rajpala gave me answer yes. Nishant gave me yes, B. Pinak A with the question mark. If you have question mark, then you can give me the answer D. That is like similar to maybe wala. Then Korea gave me answer B. The answer should be B. Obviously, we have a lot of evidence that that gives us the statement that yes, the climate and geography regulate the vehicular emission. I gave you one example. Like if you are running your vehicle in the mountainous region, then obviously your fuel consumption will be higher. Okay, if your fuel consumption is higher, then this will give you the higher emission. Obviously, means geography is giving you a different vehicular emission. If it is a plain area, then that will give you the different vehicular emission. Okay, then yes, geography regulate the vehicular emission. We accept it. Then the climate. if you have different temperature, if you have different humidity level, if you have different pressure level, then your vehicle emission will be different. For example, in if you have higher temperature at that particular region, then your VOCs will be higher, because these can because such compounds can evaporate very easily. Yes, Pinna.
If there are two cases, first one is if we are driving a car in winter, and another one is if we are driving a car in summer. So which will be more?
Tell me once again. If we are driving
Ma'am,
a
there
car.
are two cases.
Mhm.
Suppose there are two cases in which there is a one winter and summer, and
Mhm.
so which will be the more where will be the more emission means in summer or winter?
See, like if you people know that different type of pollutant will vary in winter and summer season. If you know that based on our temperature, the carbon monoxide and nitrogen dioxide, like this CO and NOx are determined by the temperature. So if your temperature is lower, then what will happen? This will give you a very uh, this will give you a very high NOx. Why? Because there is atmospheric nitrogen we have in our atmosphere that can also react, and that can also give you the nitrogen dioxide. But if you have lower temperature, then your NOx will be reduced, but your carbon monoxide will be higher, because there may not be a sufficient combustion, like there may be incomplete combustion at that position. So if we are talking about this carbon monoxide and nitrogen dioxide, then this will be opposite to each other in the summer and winter. But if you are talking about the VOCs, that is the volatile organic compound, then
Yes, ma'am.
in
VOC
the
will be higher in summer because they are volatile, so in high temperature they
yes,
will
yes,
evaporate.
exactly.
Yeah.
So we have different pollutants, and different pollutant will behave differently in different weathers. Uh, okay, so that's why the answer is B. Okay, the answer should be B. Yes, somehow I clicked on that. No, but this
I
is
was
B.
right, ma'am.
Oh, you are not right. Answer B is right. Somehow by mistake, I am circled around this A, but the answer is B. Okay, utilizing the various emission model developed in other countries, Indian domain has the limitation due to, like there is always a problem, because most of the models are developed in USA and in Europe. If we are utilizing that type of model in Indian domain, then we may have some problems with that model. So why? What are the limitations then, whenever we are utilizing such kind of models on our Indian domain? So what are the problem with that models? So I have four statement: data scarcity, difference in technology, similarity in infrastructure, difference in driving cycles, and 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 you have to select the correct statement A, B, C, D. Someone gave me answer. Nishant gave me answer D. A. Okay. Rajpala gave me answer B. Answer D should be right. Why? Because as I told you that in European country we have the data of the driving pattern, how people are driving the car, how much speed, what's the speed behavior of each vehicle per person. We have such kind of data they have. Okay, then yes, D is correct. Then such kind of data is not available in India. So there is a data scarcity. Second, difference in the technology. they are very advanced, in their vehicle, there is a very advanced and innovative engine they have, and that's why emission is uh, emission has been minimized. But if we are talking about India, data is not available, Rajbala, because like every time, like if you want to collect the data for the India, then you must have that large budget for that, and even your government should have the intention to collect such kind of data, but our government may think like that, why to waste a large fund on such kind of project to collect such kind of data. So that's why we don't have such data. Yes, Rajbala.
Madam, if data will be not available, then why we are studying about these models?
We are not okay, we are studying these models because by studying that model, it may be that some of the scientists may request to our government to give them the fund, and so that we can also collect that data. And if the government will provide the fund to the scientist, then obviously we will have data. We can also use such kind of models, and based on that model output, we can we can form some kind of policies for the future, and we can improve our techniques, even and we can improve our mitigative measures. So that's why we need to study all such kind of models. And even because we don't have such kind of data, that's why we are using the modified model, in which we need just a very simple kind of data set. We will talk about in next MCQ about that. Okay, so
Means air modeling is not static, or you can say ki air modeling in India is not good according to, yeah, our data, or our technology is lag behind to modern technology. So
yes,
the peoples who wanted to, or who want to make interest in air pollution monitoring, outdoor or maybe ambient or indoor, so they should think about to do why they are doing work in air pollution.
they are wo- see, whatever the facilities you have in India, you have to utilize it. And if you don't have the facilities, then it is better to learn new things from abroad and try to bring it in your Indian domain. So we have to study everything, no? And because we are the developing country, so no doubt we don't have some technology. We don't have that such advanced technology and even the models. But yes, at the meantime, whenever we will get the sufficient budget, and because of the collaboration with the international agency, we can also develop such kind of model. We can also collect such kind of data set that are required for such models. So obviously, we need to study everything. Is it clear,
Oh,
Raj? Yes.
okay, okay, madam. My research was also on indoor air pollution, so I am more worried about this data. Why people are not providing facility? If they know about something, then they should share. And if technology is not so much developed here, so government should take action. Otherwise, CPC we have so much budget, or those people are recruiting peoples, but they can't think about the pollution. They are giving the statements that odd or even number will be successful, but those people are not talking about what data we have, why we are giving this.
Yes, exactly. Even uh, personally, if I share you my experience, I want to work, like I have some work on the temperature data set and related to the vegetation. So in India, every scientist work on a very small domain. So for example, we have data set of a few kilometer for that vegetation, but we don't have data for the Indian domain wholly.
Yeah.
So we are facing such kind of problem. That's why we are inclined with the remote sensing, so that it can give us the data for the larger domain. We are also collaborating with the international agencies, so that they can also give us the data. So but somehow we have to manage, and because we are the future, then yes, we know the limitation of India, then we will try to bring the budget from Indian government and we'll try to implement so that we will have the good technology and even the good data we have in our India. So okay.
Okay, thank you.
So yes, data scarcity we have. There is a difference in the technology. For example, the engine type in foreign country is different from the engine type we have in the India. So yes, because of that, our output will be different. So and such models are only customized according to that technology only. So we have to customize this kind of model for our type of engine, whatever we have. So because there is a difference in technology, that's why we may not able to implement such kind of emission model in our Indian domain. Then similarity in infrastructure, this is wrong. There is a difference in the infrastructure. That's why we can't adopt such kind of models on Indian domain. And then obviously there is a difference in the driving cycle. So D should be the right answer. Okay. So as you told, why we are using, then why are we are talking about these models that we can't use? Then obviously we have some models that are related to countries like us, that countries that doesn't have that much data. So you have to tell me that particular model that can be utilized for this Indian scenario based emission. ABCD: Mobile, Vapi, Move, Scopart. Can you guess? Okay. Yes, Rajbala.
Madam, explain all the force because we have no knowledge.
Okay. You just have to see like these are the four models, and these four models, out of which three models are developed by the foreign countries, but one model has been developed uh, for countries like India, and you have to tell me only like that model that has been developed for the country like us. So this is Vapi. IIT Kharagpur or IIT Kanpur is using that model, and that model need a very low information to run that model. And so this is just the example that this model we can use for our Indian domain. So Vapi is the right answer. And here we can see what kind of data we need for the Vapi model to run. So we need vehicle kilometer travel, vehicle ownership, saturation level, human population. So such kind of data we have in India. So based on that data, we can run this Vapi model and we can have the output. Okay, I think time has been up and this is the last question, I think. Yes. Okay, thank you so much. Being very patient right here. Okay, Rajbala, yes.
Madam, please share the mail where we have to give the query for exam as well as for assignment collection, pending assignment collection.
Okay, Rajbala, can you share me your email ID so that I can personally
Yeah,
share
ma'am.
you?
Yes,
Yes,
I
yes,
will.
please share me. Tomato, I can't share you the phone number because like we can share you the email ID of this, but we can't share you the contact number.
मैडम को दिखता है, सबको नहीं दिखता.
Huh? Anyway, bye. Thank you so much to be here, and we will meet again Monday 6 to 8. Yes, Rajbala.
I have shared my email ID. Have you got it?
Yes,
Okay.
yes, I got
Okay.
it.
Okay.
I
Thank
will
you.